need to do now? So probability Z greater than 1.32 plus 0.9066 equals to 1. So probability Z greater than 1.32 equals to 1 minus 0.9066. Tell me the probability. Yes, you have to, Srishti. Yes, Amrish. It's just like a log table. It's available online also. Probability that randomly chosen person in US may generate more than 6 pounds of wastage per day. Okay, chances are 90%, 19%. How come they are saying 1.19? You misguided me. How come? I mean, you told me 1.32. That's how I have written. You told me wrong Z value actually. Sorry, then it's my mistake, whatever it is. So let me just correct it. This is not correct. And this is, I mean, something wrong. I mean, I need to repeat this again. Oh, sorry. You, okay, sorry. It's my mistake. Actually, it's my mistake. Sorry. So probability 1.19. So probability is available. So this can be available from the table. Okay. Z less than 1.19. This is available from the table. This is not available. And we are looking for Z greater than 1.19. Total is 1. Okay. Now let's try to understand. Let's read the Z table again. Okay, it's completely fine. I mean, okay, 1.1, 1.19. This is 1.1. Let me highlight it by, but our Z value is 1.19. I need to freeze the span, otherwise it's going to be very difficult. Here it is a 9. Let me just highlight this. Second decimal, 0. So this is the probability. 0.883. Okay. So this region ka probability is 0.883. तो इसका क्या होगा? 1 minus 0.883. Okay. 0.883 plus P of Z greater than 1.19 equals to 1. That means P of Z greater than 1.19 equals to 1 minus 0.883. This is going to be Are you sure? 117? Okay. So this is X greater than 6 pound. X greater than 6 pound. Okay. What is their answer? 117. Got this? Got this? They have used a different Z table. Okay, there are two types of Z table. This is a cumulative Z table. This is known as a cumulative, where the values are starting from, because here in the cumulative table, there are two values, negative and positive. And for any particular value, probability is given for a region starting from extreme left. Extreme left, matlab negative side. Okay, let me just tell you the different Z table. So in your book, this is the Z table. So this is what the Z table is given in your book. No, this one is not there. This one, I guess. This one is the same actually. Type B, yes, this is a type B. So here in this table, only positive values are there. Here only positive values are there. There is no negative values. So this is the table they're talking about. Here, whatever the Z value you're talking about is starting from the, so here based on the Z value, probability figures are given for the region starting from 0, starting from mean. पहले के table में the probability values were given for a region starting from extreme left. Okay. Here the region starts from 0. That's the only difference. Can I show you the book? Here it's a book. Page number 193. Yes, 193. Yes, please go ahead. Do you want me to read this? 1.19. So here this is 1.1. This is 1.1 and 9. For the 9, you have to select. Yeah, this is like very difficult. Okay. So this is 0.3830. Okay. Let me just discuss this also. So the Z table which is given in your book, okay, just giving you the probability value of a curve starting from 0 ends at that particular Z value. So Z value is, our Z value is 1.19, because here you can imagine a person, a US person, who can generate more than 6 pounds of wastage per day. Now, in previous example, which I have used in my Z table, which I have shown, curve starts from the extreme left, but here curve starts from the 0. Okay. Now we are looking for the probability of this region. Okay. And from this point to this, the probability is 0.50. This point to this, probability value is 0.50. Total is 1. Okay. So here for Z, here the Z value is, you can write mathematically like this way, probability that Z value is 1.19 equals to So here you can say that Z value is between 0 to 1.19, and this is greater than 1.19. Okay, and the collective probability of this is 0.50. So this can be found out from the table on the page number 193. So this is 1.1 here and the 9 and then 1.19. 3830, 0.3830. So 0.5, this is 0.3830 plus probability z equals to 1.19, implies that probability z greater than 1.19 equals to 0.5 minus 0.3830. Can you tell me the reason? I mean, can you tell me the answer? Probability that random person generate the wastage more than 6 pounds per day. So answer is same here. Answer is same. It's just just due to two type of Z tables. I hope you got the clarity. Got the clarity, yes or no? All of you are saying yes. Great. Now I can at least discuss the further topic. Superb. Okay. Dash is a normal distribution with a mean 0 and the standard deviation 1. The answer is standard normal. Each half of the distribution of a normal distribution is dash image of other half, mirror image. It's a mirror image because normal curve is symmetric about mean. When the large enough sample size are taken, many statistics are normally distributed. True. True. Normal distribution is a continuous distribution. अगर मैं कहूं false, तो मैं गलत हूं. Actually, normal distribution is a continuous distribution. Okay. Yes, it's true. If I say false, I am wrong. Okay. Area under the curve is a normal distribution. Okay. Area under curve is a normal distribution is 0. Great. So, okay, one more thing. This is like very important. I wanted to at least discuss this. A very first line of this. As I told you that many distributions, they act like a normal distribution at certain extent. Okay. So let me just talk about this also. So very first line, if you observe the probability most widely known and they used all distribution is a normal distribution. Okay. Okay. And okay. Why it's a normal, it's most widely distribution because see, many times it's like here in normal we have a series of approximation theories. Okay, approximation theories are what? So basically, let's say at certain extent your Poisson distribution act like a normal distribution. Okay, and then the expression can be derived mathematically like this. So lambda is what? Average, long-term average in Poisson distribution, right? So this way z can be found out, and under root of lambda is nothing but it's a variance. It's a formula to calculate the variance in Poisson distribution, right? Standard deviation, sorry. Okay. Secondly, approximation, right? As I said that I asked that question, and let me just ask you again. Let's say if in my data, let's say 67% data points fall into the range called mu minus sigma to mu plus sigma, and let's say in the second range, let's say instead of 95.44%, let's say 94.28% data are falling, and let's say in the third range 97% data points are falling, can't you say that my data is normally distributed? Can't you say that my data is normally distributed? So what should be the terminology for that, Priyanka? It's not exactly normally distributed, but can you say that it's approximately normally distributed? Proper word is approximation. Proper word is approximated normal. See, exact, you you will get very less number of chances, or let's say hardly you'll get opportunity to say that okay, my data follows exact normal distribution. Hardly you'll get that opportunity to say or claim that your data follows exact normal distribution. It's a, I mean, look at the criteria 68.26. For that, you have to follow 68.26, 94.44, and 99.73. Up to 2 decimal, you have to make a precision. You have to at least, you have to be precise. Okay. So many times, let's say instead of 68, 65% data points are falling. Instead of 95, let's say 90% data points are falling in the second, let's say, range. In third range, let's say in place of 99%, let's say 95% data points are falling. Then also you are going to use the same statement that your data is approximately normally distributed. Got this? Yes or no? Agree with me? Do you agree with me? Yes or no? Got the terminology? Let's say in the first range, 63% data points are falling. And let's say in the second range, let's say 93% data points are falling. In the third range, let's say 98% data points are falling. What do you call this data? If this is what I found based on my data, what do you call this? Yes, correct, Priyanka. Okay. Now approximation of binomial, because at certain, when you observe, let's say in the binomial case, when the mean is above 10 and the variance is also above 10. Okay. Binomial distribution acts like a normal distribution. This is what the approximation, binomial approximation of normal theory is saying. This theory name is binomial approximation of normal. For a bigger sample size, if you observe mean is above 10 and variance is also above 10, sorry, NPQ is also above 10, then binomial distribution, acts like a normal distribution. Okay. Even chi-square distribution acts like a normal distribution at certain extent. This is student T distribution. Again, T distribution for a larger sample size, gradually will try to at least approach its normal curve. If you talk about, these are the conditions where when the T distribution is like X like a normal distribution. Chi-square distribution, if you talk about the, look at the, PD, I mean, probability density function of chi-square distribution. Chi-square also, it's like a stretched curve. Okay. It's like a skewed curve, right hand side, from the right hand side. Look at the right hand side tail part. It's bigger than the left hand side tail part. So it's a right skewed distribution. If you increase the sample size, this curve gradually become normal. So this is normal, a chi-square approximation of the normal. Okay. Even in the case of F distribution also try to at least approach, try to behave like a normal at certain extent. Okay. I'm just trying to tell you, Now it comes to the sampling. Now you have to understand the sampling part also. This is in the chapter number 7. Oh, sorry, 6. So what is the sampling? I guess in the initial classes, somebody asked me that, okay, how we can at least, let's say, analogically speaking, if this is our population, we are always looking for a sample looks like this population. We can't accept this sample. We can't accept this. We can't accept this sample. Doesn't look like a population, right? I'm just talking about Rajiv. I simply talk about that. That was an extra thing, a bit extra thing. I'm just trying to show the usefulness of it. I was just trying to explain that first line, why it is widely used. Because many distribution approaches normal at certain extent, behave like a normal at certain extent, though the conditions are different. Okay, coming back to our discussion, if this is our population, and if we want to draw the sample, looks like a population, okay, we need to select the sample through some sampling plans. So here we are going to discuss how we should, select the sample. For that, there are various approaches. Let's discuss the first one. Uh, Basic classification, there are so many sampling plans, I mean, variety of sampling plans. But let's say if you categorize them, then there are two. First one is random, which is called probability sampling. Second one is non-random, which is called non-probability sampling. Now, what is the basic difference? So probability sampling is, for each selection, we can at least calculate the chances of a person who can be part of your sample. When mathematically you can able, or let's say when you are able to calculate the chances of somebody who can be the part of your sampling, okay, procedure and can be there in your sample, then you should perceive that the sampling technique, the way you are selecting a respondent, is probability sampling or the random sampling. Okay, this is another name of this random sampling. Say for example here, how many students are, let's say how many participants are present. Let me just take a look. There are 66 participants are there. Randomly, if I let's say in Excel, I've assigned all 60 participants. Let's say I have assigned a serial number to all 66 participants. From my Excel file, if I choose a serial number 45, and if I found that, okay, it's nothing but it's Priyanka, that means all of you have equal chances. Before the first person selection, all the people had equal chances to be there in a sample. That's called simple random sampling. Here I can determine the chances of somebody can be there in my sample. Now imagine, let me just at least discuss this similar situation. Imagine that I am curious to know that what fascinates people, particularly Instagram users, to, let's say, use reels. Nowadays reels are there, right? Reels, you can at least record your video and share it on the platform. Reels, how many of you are aware about that? Reels, all of you? Now I want to understand, I simply want to understand that how many of Indians, okay, they're using reels, and why they are using reels. I have two questions. I want to answer these two questions. Now this time, who can be the part of my population? All those Indians who are using Instagrams as well as reels. they can be the part of my, technically they are the part of my population. They can define my population. Numbers is so big. So what I can do, I can at least find out the easiest option. Let's say you people are there in my professional sphere. So I can target those people who are Instagram users and those who are using Reels in my professional sphere, or let's say personal. Okay. I can ask them. Okay. But here, all the Indians who are using Instagram, who are using Reels as well. Okay. If I focus on them, I can't say that all Indians have equal chances to be all Indians who are using Instagram, who are using Reels as well. I can't say that they have equal chances to be the part of my sample. I can't say that because their chances are not same. Their probability is almost zero because here I'm going to target those who are easily accessible to me, I mean, I'm going to target those who are in my personal or the professional sphere. So here I am unable to calculate the probability for them. That's why it's a non-random sampling. Okay, we'll discuss this concept very clearly so you'll understand gradually. So this is a broader classification of probability. Random. Sampling plan, probability, and non-probability. Okay, simple random sampling is what basically. So these are the these are the characteristics present in your population, and randomly you choose some character. Yes, this is there. This is there. So we say this is 1, 2, 3, 4, and 5. This is 1, row number 2, 3, 4, and 5. Total 25 smileys are there. Total 25 people. All people have equal chances to be selected. The probability of selection of any person, okay, that he or she can be the part of my sample is 1 by 25. Because I'm going to randomly assign the digits and then I can select them. Say for example, how can I select this randomly? Wait, let me just at least do this. Let me just explain this through a very simple exercise. Okay, let me just share my screen now. Q&A, there are 6 questions. Okay. Let's say these are the companies of Chandigarh. These are the companies of Chandigarh, and this is a unique identification number assigned to them. Okay, how many companies are there in Chandigarh? So this data is published by Ministry of Corporate Affairs. In 2018, they said that there are 14,237 companies are there in Chandigarh. Okay, 14,237. 14,237. I want to select, imagine that I want to conduct a survey. I just want to conduct a survey to understand that what kind of challenges they have faced during the lockdown. Okay, imagine that in this survey, I want to select companies randomly. What should I do? What should I do? Let me just assign the random numbers. Random between 1 to, let's say, 20,000. 1 to, let's say, 20,000. Okay, this way you can at least do it. Okay, then you just sort the data as per this. It could be anything, I mean. That's the largest or smallest. Okay, and let's say I want to select a sample of 10 companies, or let's say 20 companies. I just need a sample of 20 companies. So these are the randomly selected companies, 20 companies. Okay, so I have assigned the random numbers and sorted the random numbers in a particular way. Okay, let me just sort it again. Okay, so I've assigned the random numbers and sorted them in an order called highest to smallest. So these are the 20 out of this 14,237. So this is called simple random sampling. Now, what is the probability of any company that can be selected in my, let's say, sample survey? 1 by 14237. In this exercise, I have assigned the random numbers to all the companies, and I have selected randomly 20 companies. That means each of the companies had equal probability to be selected in my sample. Do you agree with me? Yes or no? Do you agree with me? Yes or no? Do you agree with me? Yes or no? I mean, you're not saying anything. Are you confused? Are you there? Let me just do the similar exercise. I have asked a question. Have you, let's say I want to ask this question. Have you understood this thing? Now I'm randomly selecting a person, let's say Prafulla. Then let's say Veena. And let's say Babu Francis. So before I have pronounced these three names, all the participants, currently there are 59 participants, all the participants had equal chances of being selected. So probability of each participant is 1 by 59. Got this? Yes or no? So these people in the population, all people have equal probability, 1 by 25, 1 by 25, 1 by 25. Okay. Yes, Rima. In the Chandigarh, in the case of Chandigarh, okay, I have done 18. There were 14,237 companies. I have selected 20 companies randomly for the survey to understand what kind of challenges they have faced during the lockdown. तो जो 20 कंपनी था वो मैंने सिलेक्ट किया, लेकिन उससे पहले each companies had a equal probability to be selected, और वो क्या था? 1 by 14237. Got this? Now systematic random sampling. What is a systematic random sampling? Systematic random sampling is that the first you just randomly select. Let's say randomly I have chosen this person. Then I'll select subsequent person by following a pattern. Let's say every third person is now selected. Every third person. This is the first selection, totally random. Then I'm going to select subsequent. Then I'm going to make subsequent selection by following a pattern. Let's say interval of 2. So every third person will be selected. Got this? So here every third person has equal probability to be selected. So here we can't say that all the population units have equal chances to be a third person having equal chances to be selected in a sample. Understood this? Understood this? Yes or no? Okay, if you have understood this, let me just answer this. During the exam, can we use Excel as while we are writing the exam of FA in the first sem? They didn't allow us to use anything. What should I answer? I mean, this time that is going to be online mode. So you need to at least read the exam guideline, Vijaya. Zero means I didn't understand, Pratik, what you're trying to say. Uh, Vijaya Durga saying no. I don't know. For what you say no. One last, I mean, Vijay, if you can repeat, please, what you need, what exactly you want me to repeat? Please explain. Now, Pritika Mathur is asking, Z is 189. Oh, sorry, I have noticed that, Pritika. Vijaya Durga, it was for probability. I guess you have written in the chat box. You wanted to write it in the chat box, but Vijaya, it's available, I guess. It should be available, Ankita. Without that, you can't calculate. That has to be available. If the sums, numericals are there, has to be available. If you find some examples are there, then you should at least demand for the Z table. Or you can carry it, I mean, if Z table, I mean, you can carry along with you, just like a log table. But don't write anything on it, okay? Otherwise, invigilator won't allow you to keep it. Okay, Rajiv is asking something. Please take one class exclusive to teach us how to use Excel formulas. Okay, I'll ask. Ankita Saha is asking for assignments. Do we need to make the normal distribution curve for probability? Just for your understanding, Ankita. If it is uh, mentioned in the question that you have to draw the probability curve, then only you need to, prepare. Otherwise, you don't. I don't know why you are saying. I'll make sure that next time it won't. Yes, here we close the session for the day. But before we close the session, I would. Okay, yes.